Hello everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Science. In this series, we discussed about what is clustering. Last presentation, we've seen about what is clustering, what are the algorithm we are using. Today, we are going to see the K-mean clustering. So, in K-mean clustering, in the defined stage of data science or design thinking, our main goal is to clearly understand the problem. So K-mean help us here by grouping similar data points so we can see patterns that are not obvious at first glance. By analyzing the clusters, we can better understand user behavior, system needs. By analyzing this cluster, we can better understand the problem areas. This clarity helps us move confidently towards ideation and solution development. First, we see the introduction to clustering. Clustering is an unsupervised learning. It's an unsupervised technique used to group similar data points. It groups data points that are similar to each other. This is very useful when we don't know the structure of the data in advance. Clustering is commonly used in the early stages of analysis to explore data and exact meaningful insights. So these are the pros and cons of the clustering. Here, exploratory analysis, pattern recognition, and data pre-processing, these are all the pros. And cons, no label data, algorithm selection, parameter tuning. Next, we see the what is K-mean clustering. It's a popular algorithm based on centroids. Here, we divide the data into K groups based on the similarity. Where K is decided in advance, each cluster has a center point called a centroid. So each data point is assigned to the nearest centroid, which makes K-mean simple and easy to understand. So in K-mean clustering, first we have to understand, group the data, and we have to fix the centroid point, and we clustering the data. Next, we see the how K-mean works. So let us understand the working step by step. First, the algorithm randomly select K centroids. Then each data point is assigned to nearest centroid. After that, the centroids are recalculated based on the average of the assigned points. This process repeats again and again until the centroids stop changing. At this stage, we say the algorithm is coveraged. Here is the diagrammatic representation for how K-mean works. So first we select the K random centroids. So it update centroid based on the assigned points. So centroid assignment, centroid update and iteration. So here the process is repeated again and again until coverage the reached point. Next we see the mathematical formulation. Let us understanding the working step by step. First, the algorithm randomly select K centroids. Each data point is assigned to the nearest centroid. After that, the centroids are recalculated based on the average of the assigned points. This process repeats again and again until the centroids stop changing. At this stage, we say the algorithm as converged. Next, we see that choosing the optimal number of clusters. So, choosing the right value of K is very important. The elbow methods help us to identify the point where adding more cluster does not give much improvement. The score measure how well each data point fits within this cluster. The gap statistics compares actual clustering with the random data, selecting the correct K improve accuracy and interpretation. Next, we see that one of the biggest advantages of the K-mean is its simplicity. It is easy to understand and easy to implement. It works very fast, even with large data sets. K-means also scales well, which makes it suitable for a real-world application like marketing, image processing, and recommendation systems. So these are all the effective clustering. It's a simplicity, efficiency, scalability, and wide applicability. Next, we see the what are the disadvantages of K-mean. So K-mean also has some limitations. It is sensitive to initial centroid placement. which may lead to different results. It assumes cluster circular and similar insights. Outliers can heavily affect the clustering. Also, we must decide the value of K forward, which is not always easy. So it's easily affected by the outliers. It requires predefined value of K. So it's the ineffective clustering. So these are all the disadvantages of the K-mean clustering. So the practical consideration of the K-mean is to get better results, data should be properly scaled or normalized. The choice of distance metrics also affect performance. Using K-mean helps in choosing better initial centroids, which should also be careful about empty clusters which can occur during executions. So, and the application of K-mean in real world scenarios, we used K-mean we use in marketing. It helps segment customers. In image processing, it is used to image segmentation. In text mining, documents are grouped by topics. It's also used in anomaly detection and recommendation systems. So, customer segmentation in marketing, pattern recognition and is in a image segmentation, document text clustering, detection and recommendation system. These are all the applications we are using in the real world scenarios. So, for example, in a practical example, we first normalize the data using a standard scalar. Then we apply the K-mean algorithm by specific number of clusters and the random state. So here we apply the K-mean algorithm. After fitting the model, we obtain cluster labels and centroids. Then helps visualize how data points are grouped. These are the example for how K-mean algorithm working in the large data sets. So we come to the end of this section. To conclude today's topic, so K-mean is a simple yet powerful clustering technique. When combined with proper pre-processing and correct selection of K selection, it provides meaningful insights. It works best for well separated and spherical clusters. It's widely used for insight across many domains. I hope you enjoy this section. Thank you.